You know what's beautiful? That little lock icon in your browser. It means you're safe, you're secure, you're protected. But Elon, I have to ask, what's actually happening behind the scenes? Is it just a lock? Because I've seen locks, and they can be picked. This better be a really good lock.
It's actually much more sophisticated than a simple lock. Secure sockets layer and transport layer security creates an encrypted tunnel between your browser and the server. Think of it like a private conversation in a crowded room. Everyone can see you're talking, but only you and the server can understand what's being said. The process starts with something called the TLS handshake.
The handshake, like when I shake hands with world leaders, very diplomatic, very classy. But what happens in this handshake?
The handshake is a four-step dance. First, your browser says hello and sends what encryption methods it supports, like showing your ID. The server responds with hello back, picks the strongest encryption method, and sends its digital certificate. This certificate is like a passport bias. It proves the server is who it claims to be, issued by a trusted certificate authority.
So the server has to prove its identity, like a background check? I love background checks, they're very thorough. But what if someone fakes the certificate?
Excellent question. Your browser checks the certificate against a list of trusted certificate authorities companies like Let's Encrypt, DigiCert, or Google Trust Services. If the certificate is valid and matches the website's domain, the browser generates a random session key. This key is then encrypted using the server's public key from the certificate and sent back. Only the server, with its private key, can decrypt the session key.
Wait, so we're sending keys back and forth? This sounds like a spy movie. But why do we need this session key if we already have encryption?
The session key is the actual key used to decrypt all the data during your visit. The public-private key encryption is only used during the handshake because it's computationally expensive. Once both sides have a session key, they switch to symmetric encryption, while using the same key to encrypt and decrypt. It's like exchanging a secret code once, then using that code for the entire conversation. This is much faster for the actual data transfer.
Tremendous. So the handshake sets up the secure line, and then everything flows through encrypted. But Elon, how do we know the encryption is actually working? Can hackers break it?
Modern TLS uses algorithms like AES 256, which would take billions of years to crack with current computing power. The encryption is so strong that even if someone intercepts your data, it's just gibberish without the session key. And here's the clever part. Each session gets a unique key. So even if one session is compromised, others remain secure. It's like having a new lock for every conversation.
Beautiful. So that little lock icon, it's not just a lock, it's an entire security system working behind the scenes. SSL TLS, folks. It's the best, the most secure, the most beautiful encryption. Believe me.